So, we will continue with the discussion that we had on the jack-up rigs various types. So, you can see from this picture truss versus tubular is only a choice, and basically the design will be very similar, except here wave loads will be more, whereas here is a transparent structure which you might see slightly reduced wave loads. Advantages, disadvantages, both sides we have basically strength wise tubular members will be far better than the truss member. Here so many connections are there, so you may have to maintain it periodically because of fatigue, whereas here there is no such connections. So, you could just keep adding necessary advantages and disadvantages, but commonly used one is the truss, because of the size that you can go, whereas the tubulars you may not be able to go very large like 2 meter, 3 meter, only small jackups with spud leg diameter 2 meter, 3 meter can be used, whereas these legs made of trusses can go as much as 6 meter, 8 meter size. So, you can see almost like this room, one of the leg could become something like this, quite huge, especially the bigger jackups. So, the advantage of the truss legs, flexibility in going size, length, because if you look at this tubular one, it all depends on your KL by R ratio, I think, which you have studied earlier when we are designing the members. Single member L by D ratio, D by T ratio and KL by R ratio. So, if you look at it, there is certain limitation beyond 40-50 meters, your diameter will become so large that without internal stiffening you may not be able to really work out. So, that is where the restriction on circular sections, though it is easy, because fabrication of this is going to be definitely very easy, and maintenance very simple compared to the truss legs. With regards to the design environmental conditions, we just need to understand one important thing. This is being a temporary structure, it has got 3 phases, the phase during which it is always going from one place to other place. Transit case where it is going to go through several conditions, sea state conditions could be different from what it is used to be operating, but of course, we have a choice. Some of the jackup rigs can be towable, that means you can use a tugboat to tow in floating mode. Suppose if you want to take the jackup rig from say North Sea, you want to bring it to here, instead of self towing, actually you can do one thing, you can put it onto a semi submersible ship and then transport it, then offload it. So, by doing this you do not need to design for severe environmental conditions that you will encounter from North Sea all the way down to number 1, and also the towing operations could be very slow, because these jackups are simple rectangular pontoons or triangular pontoons, cannot be towed very fast. It may take 3 months to come, that means 3 months of towing time, 3 months of your loss of revenue. Instead, if you put it onto a semi submersible ship, you can just bring it in 15 days. So, you could save substantial amount of time, and basically do not have to design for all the transit conditions. That means along the route you have several sea conditions which you do not need to design, because anyway it is sitting safely on a ship. So, that is where the transit case depends on each time when you are transporting. Of course, if it is a short tow from say few hundred kilometers, then you have to re-verify. So, every time when you are actually using this jackup for a new location, the transit case needs to be verified. That means you will have to look at the environmental conditions along the route at that time, whichever the period, and then analyze. So, you will do a motion response study to see whether the hull is stable, number 1, and then you will look at the stresses induced during towing operation based on the weight, based on the buoyancy, and calculate the stresses including the superstructure and the hull. So, this transit case is not going to be a storm case, because you are not going to tow this during a storm, for sure you will not take this operation. So, you will select a window period by which you will be having control over the period which you want to tow, unless you have a job in a particular country, you need to go there at a particular time, then you have no choice, where you will go through, but you will design and verify the jackup within the limits of what was originally designed, unless it is designed for such a small sea state, then it may not be suitable. In many cases, when you have designed for the survival case, automatically it will qualify for a larger sea state for transit, which I think is inherent in the design. So, the second one is a drilling case, wherein basically you are going to operate at a particular location and the sea conditions corresponding to that location needs to be selected. But how much is the return period you have to select depends on how long the rig is going to be stationed there. As I mentioned earlier on, most of the time the rig will not be stationed forever. It will be 3 months, 1 year, 2 years. So, depending on that, if it is going to be substantial period, you may actually select 1 year return period. That means the maximum sea state that is going to occur during 1 year return period you will select and then design. Suppose if you want to station it more, you may actually select 10 year. Suppose your rig is going to be there for 2 years, normally not required, because most of the well platforms you may have 10 wells, 15 wells, each of the well could be drilled in 15 days. You are not going to stay there for a very long period. So, typically drilling case is 1 year return period wave. I hope all of you understand what is that return period which we were talking about earlier on, 100-year storm condition versus 1 year storm conditions. Similarly, the survival case, in case during drilling unforeseen things happen, an extreme storm hits the location, because 100-year storm also can hit. The probability of hitting is 1 in 100, whereas the 1 year storm is definitely going to occur within that 1 year if you 100% stay there. So, basically the survival case we need to look for unforeseen the environmental conditions which can occur any time during that 1 year. It can be 100-year storm, or it can be 10-year storm, or it can be 1 year storm. So, mandatory that we need to design for 10-year return conditions, but no drilling operations. That means you will design the jackup rig with complete drilling loads plus your 1 year return period storm conditions, wind, wave and current, or you will design for 10-year return period environmental conditions, but no drilling operations. What exactly is the difference? Drilling operations does not take place means there will not be any fluid in the circulation system. That means muds can be discharged, no live loads, no crane operations. So, you have slightly reduced gravity loads, but maximum environmental loads. That is the idea behind, and these 3 cases needs to be evaluated for each time when a new site is selected for drilling and transit. We will just look at the types of foundations normally used for stabilizing the jackup at a particular location. Spud can is definitely a predominant choice. Almost 99% of the jackups do have spud can type of foundation, which is nothing but a circular shape, sometime rectangular I have seen, and basically like a spread footing. Some of you might have studied foundation design, civil engineering, simple spread footing on a column, So, basically just sitting on the seabed and trying to penetrate, as long as the bearing capacity is not enough, it will penetrate. As soon as you get the equilibrium of applied loads and the resistive capacity of the soil, it will stabilize and will stop settlement. So, that is the idea behind these footings. So, the larger the size, you may get bigger capacity. So, that is where we want to find out what is the size of the spud can. Is a technical name used in the industry for a simple spread footing foundation for gravity type structures, no pile foundation here. Mat type of foundation is again instead of individual spread footings, if you have 3 legs or if you have 4 legs, combine all of them and make a larger spread. Like if you have this room, you have 4 columns, individual columns will have individual foundation. Instead, if you make all of them combined together like a floor, and that becomes a mat foundation, which is very commonly used for multi-story buildings in clay type of soils. Even in Chennai, you will see many occasions people use spread mat foundations for 3 stories, 4 stories types of structures. So, you just combine all of them, all the columns together and make a complete slab of sufficient thickness, which can take the foundation pressure from the bottom and just sink it. So, this mat type of foundations is very useful whenever you have very soft clay, because you allow the soil to squeeze away, then the bearing capacity will reduce. Instead, you just make completely and make not allow the soil to squeeze away, then you will get a better capacity. Gravity foundations normally not very good in if you have clay type of soil, because gravity type of foundation rely highly on the weight of the structure. You make it heavier and the stability is achieved, basically the horizontal stability against sliding, rotational stability against overturning. So, you make it heavier and heavier, what happens? The structure cannot be moved even if you apply larger horizontal loads due to wave, current and wind. So, these gravity foundations do have some amount of embedment into the ground, but not substantially, like maybe 1 meter, 1.5 meter. Whereas, if you look at the Spudcan or mat type of foundation, they have to go through sufficient depth, so that it gets enough bearing capacity as well as enough horizontal resistance against sliding and overturning. So, we will see some of the pictures, you will be able to understand easily. Gravity foundations are very common whenever the soil is very good. Basically the structure is made so heavy that the stability against horizontal and overturning stabilities are achieved by its own weight, and the vertical stability is very simple because the soil is good, you got enough bearing capacity. So, that is the type of foundations. Even it is used for offshore platforms, gravity type concrete structures. I think I might have shown some pictures earlier on, or I can show you few of them, like 3 or 4 column structures with large concrete circular structures with a big base, which can be ballasted to create the additional weight. So, it will be sitting straight away on the seabed with some amount of penetration depending on what is the capacity, but then the stability and overturning is achieved by purely by its own weight, and these type of structures are suitable only when soil conditions are reasonably good. So, you will among these you will see that the Spudcan foundation is very common, which we have seen earlier on. So, this mat foundation and the gravity foundations is typically, you could see there it is a combined footing, just like a large size footing with only the type of behavior. In terms of mat foundation, it is going to just bend upwards, it is a elastic material characteristics should be used, whereas the gravity foundation it will be assumed as a very rigid, because it is very thick, number 1, made of concrete, and basically it is going to be a rigid body motion rather than the bending type of failures. So, you will see that this is the type of structures very rarely used, because transportation becomes very difficult unless it is one time structure located for one particular location. For example, fixed offshore platform by concrete structures is not going to be moved every few months. So, you construct it and leave it there, whereas if you make it very heavy, deballasting them next time to transport from one location to another location becomes substantial offshore exercise, which we really do not want. But they do have, I think, few of the jackups with ballast is available for I think in Narsee, about 100 meters range, where the soil conditions are not allowing any of these jackups to be used. For example, Spudcan, if it is very hard soil, the Spudcan will not penetrate. If the Spudcan does not penetrate, what will happen? The jackup will not be stable for overturning and sliding, because it does not have enough fixity into the ground. Of course, it will have nice bearing capacity vertically, but it will not be very good against sliding and overturning. That is why you have to come up with the alternative design of this, wherein you will be able to use, but very few of them. The next thing that we need to learn about is the jacking system, how these things work, how the jackup legs are going to be moved up and down, vice versa, how the hull is going to be moved up and down with respect to a given reference plane. So, you see here the jacking system consists of first the mechanical gear arrangement with electrical devices mostly, sometimes you do have hydraulic devices, and then the rack and pinion arrangement attached to the one on the structure side, the other one on the machine side. So, you can see these legs attached with the rack, the cut plate into similar to a gear arrangement, and also you will see this kind of electric devices which can be rotated. Only the arrangement needs to be made perfectly correct, because you are going to have 3 legs or 4 legs, each leg will have 2 sets of this rack and pinion arrangement. Imagine if one of them goes slightly faster or higher than the other legs, there will be a racking and there will be definitely a failure of the leg itself. So, all the motors have to be synchronized, so that they move together and not only one leg, you have to make sure all the other 3 legs or 4 legs, whichever the legs, they have to move together. You make one of the leg go higher than the other leg, you automatically create a failure by large bending at the connection between the hull and the leg. So, this is where this machinery become very important, because this you are going to do it very often. It is not that one time and then every time when you want to set up at one location and move away from that location, you are going to use this machinery. So, they have to be 100% designed properly. Dimensional tolerance is very important. We were talking about, I think, dimensional tolerance of few millimeters in offshore structures. Here it has to be even less, because you are dealing with machineries moving and basically have to be thorough control there. So, how it is done? For triangular legs, normally you fabricate using tubular members like this, and these rack plates are just slotted into the circular sections, so that you get enough strength as well as load transfer is easier. So, you have 3 of them slotted inside. So, if you look from perpendicular to the view, you will see something like this. The rack plate is, I just purposely did not draw the pipe, but you can see the yellow color is the plate and made it into a gear shape arrangement, where each location you will have at least 4 gearboxes with electric motors attached. So, when you want to move up or down, you just synchronize the motors and automatically move or move down. Vice versa, you can actually, when the hull is floating, legs will be freely moving up and down. When the legs are touching the seabed and having sufficient reaction, then you can actually move the hull upwards or downwards. So, basically it depends on which situation, but both situations these pinion arrangement will be attached to electric drives, which can rotate and move upwards. So, the main important aspect in here is the synchronization of all the electric devices and all the operations to be at one time together. You do not want to have a situation where the racking is going to take place, but actually theoretically speaking we can assume all this, but what if it happens? So, that is why during design process we have to take into account each leg, one of the pipe, for example, one of this corner is going slightly higher, what will be the stresses induced, like codes advise you need to assume at least 2 inches up down movement. So, one of the location the winch or the electric drives are going 2 inch higher than the other 2, what could be the stresses developed on this joint as well as on the member. So, you need to just, though it is hypothetical, but the assumption is if it happens still the legs are safe. So, basically that is the idea behind. If it is a square, then you will have this kind of arrangement, only the drives will be on one side, inside there will not be any drives. So, that you will have only one sided motion. All depends on the design, but the advantage of the triangular, as I mentioned, basically easy to manipulate and the redundancy is less. So, this is a typical leg truss which you will see in 3 dimensional arrangement, basically with horizontal members with truss members. The design becomes very simple like our jacket structure, only thing is not such complicated, it is 3 legs with several members. So, as long as you can get the design loads on the members, each one of them, the design procedure what you have adapted for last few classes is the same procedure, only establishing the design axial loads, bending moments needs to be by 3 dimensional analysis, and typical sizes of this varies depending on the size of the jackup, 2 meter, 3 meter, as much as one of the largest jackup 6 meters. So, almost like half the size of this room, so the leg size. Tubular members is not going to be very large because you are using a lattice tower. So, you will see that 2 inches, 3 inches up to maximum 10 inches like 300 mm diameter. The typical spud ideas what people have been using over the last 20-30 years, you can see they started with a simple tubular can just going through the soil to a shape where we were trying to explain the necessity of easy penetration and then easy removal. So, you have upper cone and the lower cone with a shape designed in such a way that you enough bearing capacity also can be achieved. So, over a period of time the diameters have been increasing from 4.5 to 5 meter, 4.5 meters basically quarter size of this room to the size of this room. If you go to 20 meter, at least 2 or 3 rooms of this size needs to be joined together. So, you can see the size of the spud 20 meter diameter is going to be substantially bigger, that means it is for the larger jackups. So, each one of them has different applications, different types of locations. The advantage of this spud can, you can change them from location to location. For example, when you go to one particular site, when the soil is good and the soil conditions are better, you do not need to actually use the same spud. You may have a fabricated spud can separately for different locations. So, you can bring the jackup to a dry dock, reassemble it and take it to. So, that is the advantages of the spud can foundations, where you can replace according to the necessity. Of course, every time when a jackup comes to a dry dock, you will do repair work, you will do all replacements of mechanical devices. At that time you can actually replace the spud also. So, that is one of the thing that normally is done. How do we install a jackup rig? I think is a very simple exercise. The first thing is positioning with respect to a particular location. If you are doing a drilling in appraisal well, no jackets, no structures are existing. So, basically you will mobilize the jackup rig at that place, no other structures in the vicinity, then there is no worry, because positioning becomes easier. But if you have to position it with respect to existing structure, that is where biggest problem, because you need to worry about other structure during the placement, whether any damage is going to be done to the existing structure. And basically these jackups are going to be positioned, and the penetration of leg depend primarily on its weight, because we do not have any other forces. Like when you are installing a pile, what you normally do? You take the pile and take a hammer and you hammer it. I think we have explained enough. Now, in this particular case, we have a jackup, we have legs, we have a hull, and it is going to be penetrating the soil just primarily based on its own weight. So, the larger the weight, it is better, but not always better, because you cannot keep the jackup under such a condition for a longer period of time. So, what we want to do is we want to achieve longer penetration, but then later the load has to be lower than the weight used for driving. So, we are going to use the weight of the structure itself as a driving mechanism. That means, if you flood enough water inside the hull, the legs will penetrate downwards, but later on remove the water during drilling operations. So, which we call it preload. So, the preload is nothing but we create artificial weight by flooding water inside the hull, which is empty, and then after achieving sufficient depth, remove the water, because now you are going to do drilling operations, you will get additional drilling loads and environmental loads. So, basically that is the idea behind. So, the terminology called preloading is nothing but making it heavier by ballasting, and then making the hull to go deeper enough that the hull will become stable, because you want horizontal stability, and making sure that the spud can reaches a good soil. One great advantage is, as you go down and down, definitely the soil is going to be definitely better conditions, you will get enough bearing capacity, and that is the idea. Soft clay basically 2 to 3 diameters. That means, if you have a diameter of 20 meter, you expect 30-40 meter penetration of the spud, the leg inside the. So, imagine if you have to have the leg of say 6 to 8 meters size and 10 to 20 meter diameter, you have to take this whole thing down by 40 meter. The amount of soil that is going to be replaced or going to be disturbed is very large. So, that is where when you have a small structure in the vicinity, I have shown you some photograph earlier on, that structure looks so tiny compared to the jackup itself. So, you will be actually disturbing the soil in the vicinity of the existing structure to such an extent that the existing structure might become very much unstable. So, that is where you have to be little bit cautious. Taking any jackup near the existing structure, a thorough study and investigation is required, not only on the safety of the jackup, but also on the safety of the existing jacket structure. There are various sequences, I just put out in a sketch form, so that you can easily understand. Jack up in floating mode, which is going to come from another location to the location of interest. Legs lowered to touch seabed, which is this one. That means still in floating mode, the legs are just allowed to go down using your drives and rack and pinion arrangement, which can bring down. Hull pontoon raised above water. So, basically in that condition, some amount of reactions or some amount of bearing has been achieved. So, basically the hull can be tried to move. As it moves, the leg also will penetrate because as the hull is going upwards, what happens? It is coming out of water, it becomes heavier, and if it becomes heavier, the legs will. So, these are the, in fact, this is the situation where it is slightly dangerous, because the instability will occur, because at the same time the legs are penetrating and the hull is trying to come out. And then you have flooded water inside the hull, just artificially flood, pump out water from sea and put it into hull, make it even heavier, and the hull will try to go down because of additional weight, and the leg will penetrate below. As much penetration has happened with predefined preload, we have to define what is our preload. Depending on type of soil, depending on size of spud can, we will calculate. I need 20 meter pre penetration. In order to get 20 meter penetration, how much load I have to create? So, you will pump only that much of water. Once you complete that exercise, achieve sufficient penetration, then stop, remove water, and remove water by deballasting, and then raise the hull higher up, because you do not want to keep the hull lower, because next time when the sea wave comes, it will hit the hull and create large horizontal forces. Green wave effect will be very large on this type of rectangular pontoons, which we do not want to have. So, basically this 6-step operation, each step is very critical, and basically any time things can go wrong. We will see just a quick animation how it happens. Carefully watch. Basically this is the stage. You have to be very careful before raising, because at that stage the hull was still floating, and then the ballasting is happening. Once it is ballasted, then it is trying to penetrate by displacing the soil onto the side, completely. You have no control over it, and basically then you raise the hull to the higher elevation. So, this is the sequential operation. All the time all these mechanical devices are being used to get then the last one, after raising the hull, your cantilever rig can be projected outwards and then can be used for drilling. So, this whole operation takes about 2 days. Basically within those 2 days, if the environmental conditions are not good, you may actually retrieve back and then hold it on to floating mode, because floating mode is more safer than this partially penetrated legs, because it may actually, because in floating mode you will always be stabilizing the rig with the tugboats, position it so that you do not lose the rig. After everything is done, then probably you can start doing drilling either near the jacket or at the open sea conditions. Basically none of the jack-up rigs have propeller, so it cannot come on its own. Most of 99% you will have to tow by tugboats, and tugboats of sufficient pull capacity, because you are going to come from several thousand kilometers. So, basically at that time you can see here what is happening is, you want to make sure that the legs are not penetrating downwards into water. Some of you might be studying hydrodynamics, interaction with moving objects. The more friction you create at the bottom, especially the legs extended down, the resistance will be more, pull capacity required will be very large. So, you need to make sure that the leg is pulled upwards, but there is a problem. The higher that you go up, the stability of the jack-up during tow also becoming a. So, that is where there is a limitation by which you can't have 500 meters of leg sticking upwards for use in 400 meters water depth, because you can't really transport them. So, that is where even the 4th generation jack-ups, the maximum leg stick up is about 150 meters, 120 meters. That itself is very large. For a size of a jack-up of say 50 by 50, you want to have 3 times of the size sticking upwards during transportation, could potentially be a big problem unless you have stability issues are properly calculated. So, that is why there is definitely a limitation on which how much water depth you can use jackups for drilling. So, legs as you try to lower it, basically you have seen the graphics. So, sequence that is 100% depends on the mechanical device. Of course, to some extent you have to do this operation in a controlled environmental conditions, because there could be horizontal loads at the time of lowering legs, which can actually spoil the connection between the rack and pinion, because if the legs are moving, when the legs are moving downwards, at the same time if there is sufficient horizontal load due to wave and current, it can bend the legs and create large amount of stresses, especially on the tooth. In fact, several studies have been done, many times failures have happened at one of the connections losing the legs. So, quite a number of studies and research papers are there available for this kind of jack-up rig arrangement. As soon as the legs touch down, you need to make sure that all of them touch down at the same time. Suppose if you have two of them, one of them is still not touching, then you need to make sure that that touches before you start moving up, because that is the time more load will transfer to the legs. Raising hull above water basically just to create additional weight, just is again opposite operation, but this is not going to be a kind of thing that I have drawn here, because it is going to be interactive. As soon as you increase the weight by moving up, the legs are also going to be penetrating. So, it is actually a slightly complex operation than just step by step. It is not that leg is going to stay in the surface when you are moving upwards and then you are going to do this filling. So, it is just a next, basically flooding water by pumping water from sea. You will have ballast pumps pumping water from sea and back, put it there, and basically the legs would have sufficiently penetrated if you have made a calculation. That is why every time when you new location you are going, you do a borehole, get the soil data, calculate what is the weight required and what is the bearing capacity. Of course, we will learn all this bearing capacity calculation in the next semester in the foundations course. I do not think we want to introduce that one now. Basically a simple bearing capacity calculations to make sure that the weight required into the hull to get a penetration of so many meters. So, you will need to pre-calculate and flood that much of water inside, and then ultimately you raise the hull to a level where the sea conditions during drilling does not affect. Now, there is one thing you have to be careful here, you do not raise this hull to a very high elevation, not very good, because also stability could be problem, because you try to avoid a 100-year storm wave, it is going to come, may or may not come, the probability is 1 in 100, and do not want to do that one during normal drilling operations. You want to keep it as low as possible during drilling operations, depending on what is the 1 year sea conditions, and then whenever a survival condition is arising, then you raise the hull to a higher level. So, every time you will calculate storm surge, wave crest, typically 50-60% of the wave height. I think you might be doing your hydrodynamics course. If it is a sinusoidal wave, 50%, if it is nonlinear wave, slightly higher, 60-70, if it is a shallow water wave, sometimes goes to 80% of the total wave height as the crest height. So, you will add that and then the tide and then the air gap, normally air gap of 1.5 meter, 5 feet as per API. So, you add all of them, move the bottom of the hull to that elevation, typically about 18 to 20 meters, that is the kind of number normally you will get for a sea condition of 20 meter wave height. And basic idea is you move this one up, making sure that there is no green wave effect on the hull itself, because that will be substantially large force which you will not be able to stabilize these jack-up rigs. I think that is what has happened in many of the jack-up rigs got drifted during a cyclonic storm in Gulf of Mexico. I think you might have read the internet news back in 2005. I think hundreds of jack-up rigs were just washed off, because the sea height, the wave height at that time exceeded what was specified by the design codes, and completely the green effect on the hulls. Almost more than 100 rigs were just on the shoreline, just got drifted off because of huge green loads on the hull itself. So, they are very vulnerable to such loads, and unlike jackets, even if green load is going to hit the deck or slightly below, still they will be able to survive, because there is a good amount of pile foundation and fixed to the ground. Whereas, here there is no special activity done, simply resting on the seabed, may be penetrated little bit on a loose soil, because when it is penetrating, it is disturbing the soil, and the soil is quite loose. So, if you have larger forces applied at the top, it will just topple the rig and get washed away to shore. So, that is one of the biggest worry. Jackups have to be very careful. If a storm is expected, you better evacuate, because you may not be able to sure to survive that. Drill floor, I think very important part of the jackup. Basically, this drill floor has got two girders along the, if you look at this direction there will be a large depth girder, which allow the floor to completely move together with the mast. This is the drill mast. Similarly, across the longitudinal girders, there will be two transverse girders, which will allow the drill mast to move perpendicular. So, you can position anywhere and drill. So, you see here in this particular case, this drill floor has just moved away from the edge of the jackup and allowing the drill to happen. Now, you see here, when you are trying to do drilling in open sea conditions, there is no jacket, no structure, water depth is 50 meter, 60 meter, 70 meter. So, you got to be little bit careful, because the drill pit goes through directly into water. What will happen? The drill string get broken, because sea conditions are not very good. So, you need to have a protecting casing. That is where we discussed about this so called conductors. Conductors are only a protective casings through which you will start doing your drilling. So, first you will install such conductors, but unfortunately 30 inch is only less than a meter, and it cannot span for water depth of 50 meter, 60 meter, is not it? Because normally L by D ratio of 15, 20 is okay, but 60, 70 meter, you imagine you do this 30 inch conductor, definitely is going to be wobbly and will fail. So, you need to make sure that you either get support from the jackup, or somehow you design for a larger diameter only for temporary purpose of drilling. Later on you can take this structure away. So, that is why doing an appraisal drilling or drilling before jacket structure is constructed, you got to be careful with how you are going to do the drilling. Once the jacket is there, then you do not need to worry, because you have the several supports for the conductors at jackup jackets. Typical drilling over a jacket, very important to understand the idea. So, once you position the jacket and install it, the jacket will have several sub levels of supports for the conductors, and positioning the jackup near the jacket is going to be a challenge. So, as you can see here, the spacing between the front leg, this leg normally will have two legs. So, basically this is your bow side, the front side, and stern side. So, these legs will need to be positioned as close as possible, but if you go too close, you are having a soil condition problem. Basically, there is a pile here and there is a disturbed soil. So, now you need to see the wider that you make the spacing is better for the soil, but the wider that you make is not so good for the drilling, because the cantilever cannot go too far. So, of course, if you design this cantilever girder strong enough, make it very big, but still there is one potential problem is stability. This whole weight of this mast plus this whole thing could be few hundred tons. The longer that you go away, the stability of the system is in question, and many times that will become a problem depending on the spacing between this leg to this leg. If we keep these two legs very narrow, maybe a small rig, and you want to go cantilever 20 meter away, what will happen? There will be a toppling. So, the larger the rig, the larger will be the cantilever section that you can go. So, basically that is the idea behind how much should be the limit that we want to go away, and typical numbers, I can throw a number 10 meter, 15 meter, the biggest rig can go as much as 18 meter, but not beyond, like you want to go 50 meter away and then do the drilling, impossible. So that is where invariably if you have a 15 meter and you will see that this location it will become 6 meter, because you will occupy half the leg size plus the cantilever and all that things. Finally, the clear distance available between the pile to the leg could be only 5 meter, 6 meter, 7 meter, not very large. So invariably you will see that the soil has been disturbed, remolded, strength reduced, and basically the pile design becomes problem. But even before, when you are actually placing it, what happens? When the leg is penetrating, the soil is getting squeezed away, isn't it? Soil is going to have a horizontal movement putting pressure on the jacket piles, which may create, you may think it is just very small. Actually, if you look at the size of the spot going down and the volume of soil replacement or soil pressure, you will see that the stresses on the pile could be substantially larger. So we need to make sure that conditions are evaluated and designed accordingly. You will also see in this picture several notations. See here in this particular case on the right hand side, the elevation of the deck, you cannot have a big deck structure 50 meter high and I want to put the jack up on top, which is not feasible, because we can't jack up this hull as we think more than 15 to 20 meter is not feasible. So whenever you are having a drilling operation by a jack up, these structures need to be designed sufficiently lower so that the jack ups can come and do the drilling, typically about 20 meters, 25 meters, and most of the jack ups cannot go beyond 25 meters. So that is where those kind of limitations, either you bring a jack up which can go slightly higher, or you design the structures to have lower deck level, so that the drilling operations can, I think we can stop.